Hello, and welcome to the Center for Sciences and Innovation, or as we like to call it here at Trinity, CSI. They call me the Center for Sciences and Innovation Building Official Robot Guide, but you can just call me CSI Borg.
So here at Trinity, we have this new building called CSI. It stands for the Center for the Sciences and Innovation. It's our new science building, and we're really proud of it. And so what we wanted to do was we wanted to develop a unique and impressive way to showcase this building to prospective students. And to do this, we developed an automated tour guide that started with the base of just a robot, and we added physical hardware components too, as well as software components too, to make it accomplish these goals.
It was an innovative project for an innovation building, and I was like, wow, I would love to get my hands on that kind of project, just to, what better way to showcase this new CSI building than with innovation itself.
So we really wanted to make the tour more interactive and user-friendly. So our first task was to make really the robot taller. So I designed a Trinity Tower scale model that makes a robot about 3.5 feet tall, gives a little bit better interface for people to use it.
Luckily, when we started the project last year, I was taking Scala. So I was kind of getting my hands wet with coding.
I think our biggest challenge was compiling all of the right things in the allotted time, getting everything accomplished that we wanted to in just a 9-month period, and still balancing, 4 or 5 other classes. And then specifically to the project, we had to focus on staying under this weight constraint that was important, because otherwise, if we go over the weight, the robot's going to operate a lot less efficient, possibly not even operate at all.
We realized that the stuff that we were trying to do with the things we were trying to do it with hasn't really been done very much, or if it hasn't been documented well. If you ask the coding team, they had to do a lot of different workarounds because ROS wasn't made to give tours, right? It was made for autonomous navigation, and so we need to incorporate those concepts into what we wanted.
Sometimes a problem seems kind of unsolvable, and you can't just give up. You have to find workarounds. And sometimes these workarounds are not going to be beautiful. It's not going to be pretty. It's not going to be polished.
One of the other challenges that's really big, that's been a deciding factor for a lot of our decisions, is the robot can't see glass. I don't know if you've been in CSI, but CSI is all glass. And the fact that the robot can't see glass is very, very problematic. And one of the ways we went over this hurdle was give it shorter goals and limit its decision making so that it doesn't go into glass.
My role in this is as an advisor. It's very hands-off because these are engineers in their senior year. They know what they're doing. They should know what they're doing. And the nature of the projects they're generally multidisciplinary, so they involve really using all the skills they've learned. And some of them are more software, and some of them are more hardware, and some of them are chemical and electrical and mechanical, but there's usually a good mix of them.
So working on this project was really cool for a number of reasons. It helped me to really see how my background in engineering has paid off. Not so much as, I have all this technical knowledge of how to, use all these formulas to build something physical, but also just to be part of a team and to think constructively and to think as an engineer when I'm brainstorming with the group.
Yeah, it makes sense to have a robot rather than have a tour guide, because Trinity is cool like that.
People will come away from the tour with wow all over their face. They will think to themselves, what was I just a part of? And I believe the eager prospective students will want to come to Trinity to design something similar with a mentality of, when can I get started on something similar?